You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Access control lies at the heart of digital security because it determines who can do what with the information systems we rely on every day. Without clear rules governing access, even the strongest encryption and most robust networks can be undermined from the inside. Access control defines which identities may interact with which resources and what actions they may perform under specified conditions. This might be as straightforward as granting a student the ability to read lecture notes but not alter them, or as complex as determining whether a cloud service can replicate data across regions. The process is rarely static. Policies must adjust as users change roles, as systems evolve, and as compliance obligations shift. Access control is not just a gate. It is an ongoing conversation between policy, technology, and business needs. The principle of least privilege serves as the compass guiding all access control systems. At its core, least privilege dictates that users and systems should only be given the permissions absolutely necessary to complete their tasks, and no more. This approach minimizes risk by ensuring that if an account is compromised, the potential damage is contained. Consider a hospital. A nurse may need access to patient charts but not to financial records, while a billing clerk requires the opposite. Neither should hold broad, unbounded access because such access invites error and abuse. Least privilege prevents creeping entitlements that accumulate silently over time, a phenomenon known as privilege bloat. In practice, implementing this principle requires careful design, regular reviews, and sometimes uncomfortable conversations about convenience versus security. Yet it remains one of the most powerful defenses in access control. Role-based access control, or RBAC, emerged as a practical way to scale permissions management across large organizations. Instead of granting rights to individuals one by one, administrators define roles, such as HR specialist, database administrator, or customer support agent, and assign permissions to those roles. Identities are then mapped to roles, inheriting the correct entitlements automatically. This structure mirrors how organizations already think about job functions, making RBAC intuitive to implement and manage. The beauty of RBAC lies in its simplicity. When a new employee joins the HR team, assigning them to the HR role instantly gives them the necessary access. Likewise, removing them from that role upon departure revokes permissions cleanly. RBAC, however, can become unwieldy if roles multiply unchecked, leading to complexity that resembles individual assignment all over again. Careful governance prevents this sprawl and preserves RBAC's efficiency. Attribute-based access control, or ABAC, offers a more dynamic alternative to RBAC by considering a wide range of attributes in authorization decisions. Instead of relying solely on predefined roles, ABAC evaluates the characteristics of the user, the resource, the action requested, and even the environmental context. For example, a policy might permit an engineer to access system logs only if they are connecting from a corporate laptop during business hours. ABAC shines in cloud environments where flexibility and fine-grained control are critical. Its policies can be expressive, using conditions that adapt to changing circumstances without requiring new roles. The trade-off is complexity. ABAC requires careful policy design and robust identity metadata. Done well, however, it enables organizations to enforce least privilege dynamically, aligning access decisions with real-time risk. Mandatory access control, or MAC, represents a stricter model where authority over access decisions is centralized and often tied to security classifications. In a MAC system, resources carry labels such as confidential or top secret, and users hold clearances that determine what they can access. Individuals cannot override these rules. The system enforces them regardless of personal discretion. This model is common in military and government contexts, where uniformity and protection against insider abuse are paramount. For example, A user with a secret clearance cannot simply grant themselves or others access to top-secret files. The rigidity of MAC can feel limiting in commercial environments, but its strength lies in consistency. It creates a world where trust is not left to individuals but codified in the very operating model of the system. Discretionary Access Control, or DAC, takes the opposite approach, granting resource owners some degree of authority to decide who may access their data. A file owner, for instance, may set permissions to share documents with colleagues. While DAC offers flexibility and empowers users, it also introduces risk, since owners may lack the expertise or awareness to make safe decisions. Misconfigurations can inadvertently expose sensitive information, especially in environments where sharing defaults to anyone with the link. DAC can be appropriate in smaller or more collaborative contexts, but requires oversight to prevent accidental overexposure. In contrast to MAC's rigidity, DAC emphasizes autonomy, but that autonomy comes at the price of potential inconsistency. Balancing user empowerment with systemic safeguards is the challenge of applying DAC responsibly in modern systems. Identities themselves come in many forms, and access control must account for each category. Human users represent only part of the picture. Service principals, such as cloud applications or APIs, need their own credentials to function. Machine identities, like virtual machines or containers, often require access to secrets or configuration data. Third-party identities, such as contractors or partners, add further complexity with external trust boundaries. Treating all identities uniformly ensures that permissions are not overlooked simply because an entity is non-human. For example, an overlooked machine account with broad access may become a perfect entry point for attackers. Recognizing that identities are diverse, yet all equally critical to govern, expands the scope of access control beyond employees to encompass the full ecosystem of modern computing. Another dimension of control involves attaching policies directly to resources. Resource policies specify what actions can be taken on the object itself, evaluated at the moment of request. A storage bucket might enforce that only certain users can write, while others may only read, regardless of what their broader roles suggest. This model distributes decision-making authority, embedding protection at the data's boundary rather than relying entirely on central identity systems. It is like a locked cabinet in an office. Even if someone has a master key to the building, they still need the specific key for that cabinet. Resource policies provide that granular safeguard, ensuring that sensitive objects retain their own layer of defense. Permission boundaries and scopes add further guardrails to ensure privileges never exceed intended limits. Even if a role or policy grants broad access, boundaries can impose a ceiling on what an identity can actually do. This is particularly valuable in complex environments where overlapping grants might accidentally elevate permissions. By defining explicit boundaries, administrators guarantee that the maximum effective privilege is constrained to what was approved. Think of it as a speed governor on a vehicle. The car may be capable of higher speeds, but the governor ensures it never exceeds a safe limit. Permission boundaries ensure access remains predictable, controlled, and in line with organizational risk appetite. Contextual conditions bring situational awareness into access decisions. Permissions may depend not only on who the user is and what resource they seek, but also on factors like the time of day, the location of the request, the device's health posture, and whether multi-factor authentication is active. These conditions turn static access into adaptive control, raising the bar when risk increases. For example, an employee might be allowed to download reports from the office, but only view them read-only when traveling abroad. Contextual conditions acknowledge that security is not one-size-fits-all. It adapts to circumstances, striking a balance between usability and protection. By layering context, organizations bring nuance and resilience into their access models. Separation of duties serves as another essential safeguard, preventing fraud and error by splitting critical operations across different individuals or systems. For example, in financial systems, one person may initiate a payment while another must approve it. In cloud environments, this might mean that the developer who writes infrastructure code cannot also approve its deployment. By dividing authority, separation of duties ensures that no single identity can execute risky actions without oversight. It mirrors centuries-old governance practices, where power is distributed to prevent abuse. The principle remains timeless. Accountability strengthens security, and collaboration reduces the risk of missteps. Break glass access recognizes that emergencies sometimes require extraordinary powers. In such scenarios, predefined identities with elevated privileges can be activated, but only under strict conditions with detailed auditing. These accounts serve as digital fire axes behind glass, rarely used, carefully controlled, and immediately reviewed afterward. The idea is not to deny emergency access, but to ensure it is transparent and accountable. Break glass mechanisms balance operational continuity with security, ensuring that in a crisis, such as a widespread outage or a major breach, administrators can act quickly without undermining long-term governance. The existence of these controls emphasizes that security planning must account not only for routine operations, but also for rare, high-stakes events. Just-in-time access introduces a proactive refinement of least privilege by granting elevated rights only when needed and only for as long as necessary. Instead of holding standing privileges indefinitely, users request access for a task, receive a time-bound grant, and see it expire automatically afterward. This sharply reduces the window of exposure and eliminates dormant entitlements that attackers love to exploit. For instance, a support engineer might request temporary access to a production database during an incident, then lose that access within an hour. JIT access embodies the principle that access should be precise, temporary, and aligned with actual need, shifting privilege from a static state to a living, time-sensitive process. Approval workflows and ticket linkage provide the governance structure behind entitlements. Rather than granting permissions ad hoc, requests are tied to formal processes that capture business justification, manager approval, and sometimes security team oversight. Linking these requests to service tickets creates an audit trail that can be reviewed during audits or incidents. This formalization transforms access control from a technical toggle into a business decision, rooted in accountability and transparency. Much like expense reports or procurement approvals, access requests require justification and oversight. This process ensures that entitlements are not only technically sound, but also organizationally appropriate, reinforcing the alignment of security with business objectives. Entitlement catalogs bring order to what might otherwise be chaos. They standardize sets of permissions for common roles, applications, or environments, making it easier to assign rights consistently and avoid accidental over-provisioning. Instead of crafting unique policies for every request, administrators can draw from a curated library of entitlements that reflect best practices. This standardization reduces errors, speeds up onboarding, and ensures that permissions are appropriate and aligned with least privilege principles. It is similar to a menu at a restaurant. Customers select from a vetted list rather than inventing dishes on the fly. Entitlement catalogs transform access control from an improvised art into a disciplined, repeatable practice, providing both efficiency and assurance. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. At the level of the data itself, controls can be applied with striking precision. Data layer controls extend beyond broad permissions to govern how specific records, columns, or even objects are exposed to particular users. A sales representative, for example, might see only customer accounts within their region, while a data analyst might see transaction amounts but not customer names. These restrictions bring least privilege into the very structure of the data store, reducing the likelihood that sensitive information is overexposed. Row-level, column-level, and object-level controls transform databases into nuanced guardians of information, making sure that users see only what they are entitled to see. In cloud services where data lakes and shared platforms are common, This fine-grained enforcement is essential to balance openness for analytics with privacy for individuals. Auditing is the twin partner of access control, providing the record that confirms whether rules are functioning as intended. Fine-grained auditing captures exactly who accessed what data, when, from which location, and with which operation. These records form the digital equivalent of CCTV footage in a secured building, not only deterring misuse, but also enabling investigations when anomalies occur. In regulated industries, audits also prove compliance with privacy and security mandates, offering confidence to partners and regulators. Without auditing, access control policies operate in the dark, their effectiveness unverifiable. With it, every action becomes part of an accountable story. The key challenge is balancing the completeness of auditing with performance and storage demands, ensuring visibility without overwhelming the system with noise. Privilege escalation remains one of the most dangerous pathways for attackers, who often start with a low privilege foothold and search for ways to accumulate greater authority. Misconfigurations, overly broad permissions, and unmonitored inheritance paths can all create opportunities for escalation. A seemingly harmless read-only permission may combine with another overlooked grant to enable write or administrative control. Blocking these chains requires not just initial design but ongoing analysis, testing, and tooling to detect and prevent unsafe privilege combinations. Think of a castle. A crack in the outer wall, a neglected guard tower, and an unlatched inner gate might together allow an intruder to reach the keep. Organizations must continuously search for and close such privilege pathways before adversaries exploit them. Because entitlements shift over time, access recertification provides a structured way to ensure they remain valid. Periodically, managers and data owners review who currently has access and confirm whether it is still appropriate. This review is more than a compliance checkbox. It is a moment to align access with present-day roles, projects, and business needs. Recertification catches permissions that may have been necessary 6 months ago but are now excessive or irrelevant. It is similar to cleaning out a closet. Without regular attention, items accumulate that no longer serve their purpose, creating clutter and risk. By scheduling recertification cycles, organizations keep their access footprint lean, accurate, and justifiable, reinforcing the principle of least privilege through deliberate oversight. Left unchecked, orphaned identities and stale permissions accumulate silently, increasing the attack surface. These may include accounts belonging to former employees, service identities for retired applications, or permissions that were granted for temporary projects but never revoked. Attackers prize such forgotten footholds because they often escape monitoring and rarely raise alarms. Automated detection and removal of orphaned identities ensures that the environment remains tidy and defensible. Tools can flag accounts with no recent activity, identify unused permissions, and trigger reviews or automatic cleanups. This hygiene practice resembles pruning a garden. By removing dead branches, you not only improve the appearance, but prevent disease from spreading. Security grows stronger when entitlements are continuously pruned and refreshed. Delegated administration introduces nuance by giving local teams authority over specific resources, environments, or actions, while keeping broader control centralized. For example, a development team might manage access to its own test environment without holding permissions to modify production systems. This empowers teams to work efficiently while reducing the risk of overreach. Delegation, when carefully scoped, supports agility without diluting governance. The challenge lies in drawing the boundaries clearly and enforcing them reliably. It is like granting a tenant authority over their apartment, but not the entire building, autonomy within defined limits. Delegated administration aligns with organizational realities, where different groups must operate independently but under a shared security umbrella. Cross-account or cross-tenant access is another critical aspect of cloud security, particularly when organizations span multiple business units, cloud providers, or partner ecosystems. Such access is enabled through roles, trust policies, and scoped tokens that allow identities from one domain to act in another, but only under explicit approval. This is essential for scenarios like managed service providers needing temporary rights to a customer's environment. The complexity lies in ensuring that trust is never broader than necessary, and that revocation is immediate when the relationship ends. Without careful design, cross-account trust can become a hidden tunnel between systems, ripe for exploitation. Properly managed, it becomes a controlled bridge that facilitates collaboration while maintaining clear, enforceable boundaries. Short-lived tokens and ephemeral credentials reduce the dangers of long-lived secrets. Instead of relying on static passwords or keys that may remain valid for months, systems issue temporary tokens that expire quickly. If stolen, these credentials have little value because their window of usability closes rapidly. This model also simplifies revocation. Rather than tracking and invalidating countless static keys, the system naturally cycles them out. Cloud providers have embraced ephemeral credentials for services and APIs, allowing automation without exposing long-term risk. It is akin to issuing a visitor badge that works only for a single day, rather than handing out permanent keys. By reducing standing privileges, ephemeral credentials embody least privilege in time, as well as scope. The principle of least privilege extends directly to cryptographic key management. Access to encryption keys must be as tightly controlled as access to the data they protect, if not more so. Allowing broad key usage is equivalent to unlocking all the doors with a single master key left unguarded. Strong access policies ensure that only authorized services or individuals can request key operations, and only under appropriate conditions. Logging, monitoring, and separation of duties apply here as much as anywhere else. When keys are governed by least privilege, even a breach of one component does not unravel the entire system. Protecting the protectors, the keys themselves, reinforces the overall security posture and closes a common avenue of attack. Anomaly detection enhances access control by watching for behaviors that deviate from established patterns. A user downloading far more data than usual, or logging in at unusual hours from an unexpected location, may indicate misuse or compromise. Machine learning and statistical models can highlight these deviations, prompting investigations before damage spreads. Anomaly detection does not replace policies, it augments them by providing a safety net against novel or subtle attacks. In the same way that financial institutions flag unusual credit card purchases, access anomaly systems help organizations notice when something is off, even if rules technically permit the action. It transforms access control from a static gate into a living system attuned to behavior. Policy as code represents a modern approach to authorization, where rules are expressed in machine-readable languages and integrated directly into development pipelines. This allows policies to be tested, versioned, and validated before deployment, much like application code. By embedding authorization into the lifecycle of software, organizations avoid ad hoc exceptions and drift between environments. Runtime enforcement ensures that policies remain consistent, no matter where workloads run. This method turns access control into an auditable, repeatable practice, closing gaps between intention and execution. It is comparable to building safety codes being embedded into construction blueprints rather than left to on-site improvisation. Policy as code strengthens governance while streamlining developer experience. For organizations under scrutiny, evidence generation is non-negotiable. Auditors, regulators, and partners require proof that access policies are not just written but enforced. Evidence packages may include current access lists, snapshots of policy configurations, and signed attestations showing that reviews occurred on schedule. These outputs transform invisible controls into verifiable artifacts. Without them, trust must be taken on faith, which is unacceptable in regulated sectors. Evidence generation demonstrates discipline and transparency, assuring outsiders that least privilege and access governance are not aspirational but operational. In essence, it provides the paper trail that secures both compliance and credibility in a skeptical world. Least privilege tuning is an ongoing refinement process, not a one-time act. By analyzing logs of actual usage, administrators can identify permissions that are never exercised and safely remove them. This iterative trimming ensures that grants remain proportional to need, reducing risk without impeding work. It is similar to tailoring a suit. The initial cut may be close, but repeated fittings produce a perfect match. Without tuning, entitlements grow bloated and unwieldy. With it, access models remain lean, precise, and aligned with evolving business requirements. Regular tuning embodies the continuous improvement mindset, essential to sustaining strong access control at scale. The principle of deny by default, paired with explicit allow policies, anchors modern authorization. Instead of assuming access unless forbidden, systems assume denial unless explicitly permitted. This flips the default from permissive to restrictive, eliminating unintended privileges that might creep in through wildcards, inheritance, or vague policy language. Deny by default policies may feel strict, but they establish clarity and predictability, making it far harder for attackers to exploit oversights. It is like a locked door policy in a workplace. Employees must be given keys intentionally, not left to wander in and out at will. Explicit allows ensure that access is granted consciously and transparently, strengthening both security and accountability. From an exam perspective, understanding when to apply RBAC versus ABAC, or how to enforce least privilege effectively, is crucial. The Security Plus exam often presents scenarios where you must weigh simplicity, flexibility, and risk. RBAC may be best for large organizations with well-defined job functions, while ABAC may fit dynamic, cloud-native environments. Least privilege underpins both, ensuring that entitlements remain proportional and justifiable. Connecting these models to operational realities, such as JIT access, break glass accounts, and entitlement reviews, demonstrates both theoretical knowledge and practical insight. Exam readiness depends not just on memorizing terms, but on appreciating how these models reinforce one another in securing data. Access control is not merely a checklist of policies. It is the living framework that ensures trust in every digital interaction. By combining RBAC's clarity with ABAC's adaptability, and by grounding both in least privilege, organizations create environments where data is both usable and secure. Layered controls, from contextual conditions to deny by default rules, add resilience, while auditing and evidence generation guarantee accountability. As cloud systems grow more complex, principled access governance becomes the difference between chaos and order, between exposure and assurance. In summary, disciplined enforcement of access controls delivers controlled, auditable, and context-aware protection, allowing businesses to innovate confidently while keeping sensitive data firmly under lock and key. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.